Hello everyone, welcome back to my channel. We are solving CBSE 2026 Maths Standard Paper Set 1, Section A, and in the previous videos we have solved first 10 questions. So if you have not seen those videos, go and watch that first. We are starting with the 11th question here, which is from the chapter Trigonometry. If twice of sin A is equals to 1, then what is the value of tan A plus cot A? Okay, so what is given to me is twice of sin A is equals to 1. Therefore, we can write that sin A is equals to 1 by 2. Now, we have to calculate this value. If we could find the value of the angle A, then we can find the solution to this question. So, you have to think about now what could be the value of A here so that the value of sine of that angle is 1 by 2. So, we know very well that since sine 30 degrees is equals to 1 by 2, therefore, you can write A is equals to 30 degrees, correct? If A is equals to 30 degrees, then we will put the value here. So, we have to calculate tan A plus cot A, that is equals to tan 30 plus cot 30. The value of tan 30 is 1 by root 3 plus the reciprocal of this value, it is root 3. We'll take the LCM here and solve this. So this will be 1 plus root 3 multiplied by root 3, that will be 3. And the answer we are getting is 4 by root 3. So we have that in option number B. That means option B is the correct answer for this question. Let's see the next question. Question number 12. From a point on the ground which is 60 meters away from the foot of a vertical tower, the angle of elevation of the top of the tower is found to be 45 degrees. The height in meters of the tower is. So this is the question which is related to applications of trigonometry chapter, right? Let's try to draw the diagram here. Okay, from a point on the ground. So first of all, we have to draw the reference line or ground line or horizontal line. So this is the horizontal line. Let's suppose that this is the point on the ground, which is point P, which is 60 meters away from the foot of a vertical tower. So let's suppose we have a vertical tower here at this point. This is the vertical tower. Let's suppose the name is A, B. So from the foot of this tower, the point is 60 meters away. Okay, so this is 60 meters away. That means BB distance is 60 meters. The angle of elevation of the top of the tower. So the point is on the ground. So definitely this will be the angle of elevation, right? And it is 45 degrees. That's it. This is our diagram. We have to find the value of AB, which is the height of the tower. Okay. So this is how you draw the diagram. Let's proceed here. Yes. Look at this triangle ABC here. Angle C is equals to 45 degrees, which is the angle of elevation, right? BC distance is 60 meters. We have to find the height of the tower, which is H. So in triangle ABC, tan 45 degrees, that's equal to perpendicular divided by base. Okay. So this is the perpendicular here and this is the base here, correct? Tan 45 degrees is equals to 1. Perpendicular means the height of the tower, AB or H we can take. Base is 60 meters. Okay. So H value is also equals to 60 meters. That means the height of the tower is also 60 meters. See, look at the diagram here. It is very obvious that if this value is 45 degrees, tan 45 degrees is 1. That means these two ratios has to be same, right? So that is why the answer is option number C for this question. Okay. Moving on to the next question. Okay. In the figure, P and PB are tangents to a circle. Let me show you the figure here. Yes. So PA and PB are tangents to the circle centered at O. If OAB is equals to 15 degrees, this angle is given to us as 15 degrees, then APB equals what? Okay, so basically this angle we have to find out. Let us join these 2 points also. Here we can observe that OB and OA both are the radii. That means if OAB is a triangle now, basically it becomes an isosceles triangle. How? OA is equals to OB, so these two sides are equal. Angles opposite to the equal sides are also equal angles. So OB is equals to OA, both are the radii. So this, if this angle OAB is 15 degrees, then angle OBA is also 15 degrees. This is 15 degrees, right? Now in triangle OAB, 15 plus 15, that is 30 degrees. That means this remaining angle is what? 150 degrees, correct? Right? Now there are two ways to solve this question. Let me show you here. Method 1. In method 1, what we are doing is we have calculated this angle AOB, which is 150 degrees. Now, by the first theorem, we know that the tangent at the point of contact, is perpendicular to the radius to the point of contact. Basically, OB is perpendicular to PB and PA is perpendicular to, and OA is perpendicular to AP. Okay, so this angle is 90 degrees. Now, if you, and we have already found this angle as 150 degrees. So you can consider this quadrilateral. Okay, so in quadrilateral OAPB, angle O is equals to 150 degrees plus this angle here is 90 degrees plus this angle OAP is also 90 degrees plus this angle we have to find out. Okay, so angle APB, because sum of interior angles of a quadrilateral, that is 360 degrees. So angle APB is equals to 360 degrees minus 330 degrees, that is the summation of all these values. So the answer for this question is 30 degrees. This is one way. Okay. Now, if we know these angles, see, there is one more way here in which we don't have to find this 150 degrees. These angles are 15 degrees and this complete angle is 90 degrees. That means this angle from here to here, we can find it as 90 minus 15 degrees, which is nothing but 75 degrees, correct? If this is 75, then this is also 75 degrees. How is that true? Because PA is equals to PB, that is the second theorem of the circle, right? So length of tangents drawn from an external point to a circle is always equal, correct? So that is by the theorem 2 also we can solve this question. So that is your method 2, in which we don't have to find the angle AOB. So method 2, this angle here, it is 75 degrees. So you can write here, since PA is equals to PB, in the brackets you can write by theorem 2. What is that theorem? The length of tangents from an external point to the circle are always equal, correct? Now, these two angles, that is angle PBA plus angle PA. Okay, let's directly write it here. Yes. So, right, this is 75 degrees. This is also 75 degrees plus this angle, that is your angle APB, is equals to 180 degrees. So angle APB is equals to 180 minus 150, which is again equals to 30 degrees. So use of theorem 1 is here. The tangent at is perpendicular to the radius to the point of contact. This is your theorem number 2. Both ways are possible to solve this question. I hope this is clear. Moving on to the next problem, which is again related to circles only. Look at this. This is the question given to us. In the given figure, PA and PB are tangents to the circle. We know that these two lengths will be equal by the theorem number 2. If AOB is equals to 30 degrees, then APB equals what? Okay. Just now we have seen that this angle here is 90 degrees. This angle here is also 90 degrees. Correct? Now, if that is the case, we can find the value of angle P very easily, right? Because again, it's a quadrilateral, right? So let's look at this value. Yes, we can see here that in the quadrilateral, again, in the quadrilateral OAPB, 130 degrees plus 90 plus 90 plus angle APB is equals to 360 degrees, sum of interior angles of a quadrilateral, right? Now this angle APB is equals to 360 degrees minus, this will be how much? 310 degrees, correct? And the answer will be 50 degrees. Okay. All right. So 50 degrees, that is option number B is the answer for this question. See, there is one observation we can see from this question. Let's observe one thing here. In the last question also same thing happened. Look at this. Can I say that the angle at the center, okay, the angle, see, if you look at this angle APB, this is the angle which is made between the tangents, right? So this is the angle which is made at the tangents. Now, this is the central angle, right? And this angle. So these two angles will be always supplementary, isn't it? Supplementary means the sum of these two angles will be always 180 degrees. Why is that? Because see, these two angles will be always 90 degrees. That's a fact, right? By the theorem number 1. So we can observe that the angle between the tangents and this central angle will always be supplementary angles. So from now onwards, you can directly put the value here. If this is given to you, just directly find this value. Let's go back to the last question. You can observe the same thing here. This angle we found that it was 150 degrees and the answer was 30 degrees. See here 150 plus 30, that is again 180 degrees. Correct? So here also these two are supplementary. Same thing is happening here also. Okay? I hope this is clear. So that was an observation. Moving on to the next question here. Yeah, this is very interesting. Area of a segment of a circle of radius r and the central angle 60 degree is. So let's look at the diagram here. Yes. Area of the segment they are asking. So let's see. This is the segment. So how do we calculate the area of the segment? There is a formula here. Area of the minor segment is calculated as, this area can be calculated if we calculate the area of minor sector, that is this is the sector. Okay, this complete here is the sector. And from this area, if we subtract the area of this triangle, area of this triangle AOB in this case, so we'll get our answer. Central angle, that is AOB, is given to as 60 degrees, right? Now let's observe one thing about this triangle. This is 60 degrees. O and OB Both are the radius, so these two are equal. So can I say that this is an equilateral triangle, right? This is 60 degrees and this will also be 60 degrees, right? So triangle AOB is an equilateral triangle. If that is the case, then this question becomes very easy for us. Why? Let's see here. Minor sector area, we know that it is central angle theta by 360 into pi r square. Okay, that's the area of minor sector minus area of triangle. This is an equilateral triangle. I know the direct formula for this, that is root 3 by 4 side square. So what, let's suppose this is the radius, this is the radius. If all sides are equal, then definitely, if this is an equilateral triangle, all sides are equal. So side is radius. Okay, so root 3 by 4 radius square. That's the formula. Direct formula for area of an equilateral triangle. Correct? Now this is 60 degrees that is given to us. So 60 divided by, this is 60 divided by 360. So that becomes 1 by 6. And the answer will be pi r square divided by 6 minus root 3 by 4 r square. Do we have that in the options? Yes, we have that in option number C. Now the question comes, what if this is not an equilateral triangle? Then what is the formula to calculate the area of such kind of triangles? So there is one more formula actually, which is to calculate the area of any kind of triangles. There is one more formula and that goes like this. Okay, let me write that formula here. Area of minor segment is equals to area of minor sector minus again area of triangle AOB, correct? Now we know this formula, so I'll put the value here, 60 divided by 360, that's pi r by pi r square by 6. Okay, and what about this? What is the general formula? So that is r square by 2 sine of theta, that is sine of 60 here. This is the formula. Let's try to calculate the answer with this formula also, where r is the radius here. So this is r square by 2 and sine 60 degrees is equals to root 3 by 2. Okay. So are we getting the same answer? Yes. The answer is pi r square by 6 minus root 3 by 4 r square. So still we are getting the same answer. Okay. All right. So yes, in this video we have solved question number 11 to 15, right? So as I said, consistency is the key. So stay tuned for the next video. See you next time. And please like, share and subscribe the channel. Till then, keep learning, keep smiling and have a wonderful day ahead. Thank you.